Good morning, everyone. I am Kadir Gosanu. I am presenting our project Advanced Transaction Risk Scoring using classification models. These are my team members. So, coming to the introduction, in recent years, digital payment systems and online payment transactions have grown very rapidly. With this growth, the number of fraud cases and cyber attacks have also been increased. Traditional fraud detection systems mainly uses the rule-based methods, but these methods are not effective in identifying complex and new fraud patterns. To overcome this, machine learning techniques are very useful, which can be analyze large amounts of the transaction data and also detect suspicious behavior more accurately. Instead of just classifying the transactions as fraud or legitimate, risk scoring assigns a probability to each transaction, will helps in better decision making. So in this project, we will going to develop a classification based transaction risk scoring system by using the machine learning. Coming to the problem identification, due to the rise of online banking and e-commerce, the number of digital transactions has increased significantly. However, the traditional fraud detection systems are limited because they cannot detect new and complex fraud patterns. They only provide a binary output, either a fraud or legitimate, and do not indicate the risk level of the transactions. So, because of this limitation, it becomes very difficult to identify high risk transaction in the advance. Therefore, there is a very needful for the machine learning based risk scoring system, which can easily analyze the transaction data and also predict the level more accurately and efficiently. Thank you.
Hi everyone, I am Mohammed Junaid. I am from CSC department. Now I am going to explain about literature survey. The literature survey is an important part of our project because it helps us to understand what research has already been done in the field of fraud detection and what gaps still exist. In recent years, many researchers have focused on improving fraud detection using machine learning techniques instead of traditional rule-based system. First come to the first newspaper, that is Jaintal 2022. This study focused on detecting credit card fraud using different classification algorithms such as logistic regression, random forest, and support vector machine. The main contribution of this paper is that it compared multiple models and showed that machine learning provides better accuracy than traditional methods. Key takeaway that using simple and multiple classification models and comparing them helps in selecting the best model for fraud detection. Let's come to the second, that is Wu et al. 2024. This research introduced deep learning models for fraud detection. One important challenge they addressed in the imbalanced dataset problem, where fraud transactions are very few, normal transactions are very large. To solve this, they used the technique called SMOTE, that is synthetic minority oversampling technique. Key contribution of this technique was improved accuracy using neural networks, used probability based outputs instead of binary classification, handled imbalanced data effectively. Let's come to the third, that is Chen et al. 2025. This paper is a review of recent fraud detection technique from 2019 to 2024. It compares machine learning models, deep learning models, and assembled techniques. This study highlights that classification algorithms are widely used, like risk scoring systems are most useful than just fraud and not fraud classification. Hybrid and assemble models can improve performance. This key takeaway helps us to know that modern systems should focus on risk scoring and model comparison rather than just detecting fraud. Overall insight from our literature view will come to know that traditional systems are not sufficient for modern fraud detection. Probability based risk scoring is more informative. Next, coming to the objectives. Based on the literature, we defined the following objectives for our project. Analyze historical transaction data. We use a dataset from Kaggle or any other dataset, like to study the transaction patterns, understand features like amount, time, etc. This step is important because machine learning models learn from past data. Second, develop machine learning classification models. We implement different models such as logistic regression, decision tree, random forest, and KNN. Each models work differently. The goal is to our goal is to train and test these models. And Third is generate probability based risk scores. Instead of just giving output as fraud or not fraud, our system gives a risk score that is 0 to 1. Example, 0.2 will come to the low risk, 0.6 medium risk, and 0.9 high risk. This helps banks make better decisions instead of just blocking transactions. Next, classify transaction into risk level. Based on the risk score, transactions are categorized into low risk, medium risk, and high risk. This makes the system more practical and easy to use. Next, let's come to the last. Compare models and visual results. We compare our model performance using accuracy, precision, and recall, and displays results using graphs, charts, and dashboard. This helps in selecting the best performing models. Thank you.
Thank you, Junaid. This is Maksud. Now I am going to explain the scope of the project. What is the main scope of the project? First, we come into the system works on the transaction database. It means the this project uses a collection of past financial transaction like payment history, transfer, purchase history. These data sets includes details such as amount, time, and location, user behavior, etc. By analyzing these data, the system learns the pattern from the normal and suspicious activities. We use historical transaction data to understand how normal and fraudulent transactions look. Next, coming to the supervised machine learning models are used. In this project, supervised machine learning models are used. The system uses the supervised machine learning, means data is already labeled as a fraudulent and are a non-fraudulent. These models learns from the this label data and builds a predictable system. For example, ML models are logistic regression, decision tree, and random forest. We are going to train the system using the label data so it can predict whether a transaction is fraudulent or not. Next, coming to each transaction is assigned a risk score. By using risk score, we are assigned the transaction. Every transaction is analyzed and give a risk score. This score indicates how likely the transaction is fraudulent. For example, point 0.1 score is there is low risk, where a point 0.9 score is there means high risk. Each transaction gets a score that tells us how risk it is. Next, coming to transaction are classified into a risk level. Based on the risk score, transaction are grouped into low risk, medium risk, and high risk. This helps banks or system decide what action to take. The it allow transaction flag for review and block the transaction. Next, no real-time banking integration. Currently, the system works on stored data that is offline. It does not directly connect with live banking system, so it cannot detect the fraud instantly as a transaction happens. uh, Coming to future scope, real-time fraudulent detection. Future improvements includes the Future improvements includes detecting fraudulent instantly as soon as transaction happens. It will be analyzed in real time. This helps in preventing fraud before completion. Next, banking system integration. The system can be connected with actual banking platforms. This allows live monitoring, automatic alerts, immediate blocking of suspicious transaction. AI based AI based adapting risk score means instead of fixing rules, the system will use the advanced AI. It will continuously learn and improve the based on new data. It can adapt to new fraud techniques, changing user behavior. And coming to next slide, a requirement analysis. In hardware, we required the laptop PC minimum of 8 GB RAM, and internet connection. Software requirement is Python, Google Colab for the better GPU, and VS Code for code editing, and last one is Power BI for better dashboard. And we're collecting Kaggle data set, credit card, fraud data set. Thank you. Next will be continued by my another teammate.
Hello everyone, I am Afsan Khan. Now I am presenting our project methodologies. Step 1, transition data set. This is the starting point of the system. It contains all financial transaction data such as amount, sender and receiver details, time and location, transaction type. This data can include both normal and fraudulent transitions, which helps in training the model. Second step, data pre-processing. Raw data is usually messy, so we clean and prepare it. Remove missing or duplicate values, convert categorical data into numerical form, normalize or scale values. This step ensures the data is accurate and ready for analysis. Third step, future selection. Here we select only the important attributes from the dataset. For example, transition amount, frequency of transitions, location mismatch. This helps reduce complexity, improve model accuracy, speed up processing. Fourth step, machine learning model. We apply different ML algorithms to detect fraud, like logistic regression, random forest, decision tree, k nearest neighbors. This model learns patterns from past data and predicts whether a transaction is fraud or genuine. Fifth step, risk score generation. After prediction, the system assigns a risk score. Low risk means safe transactions, medium risk means suspicious, high risk means likely fraud. This makes it easier for banks or systems to take action quickly. Sixth step, risk classification, final decision. Based on the risk score, transitions are categorized clearly. Low means allow transitions. Medium means monitor or verify. High means block or alert. This stop converts model output into real world decisions. Seven step visualization dashboard. All results are shown in a dashboard, graphs and charts, fraud versus genuine statistics, risk distribution. This helps users understand insights easily without technical knowledge. Final output. The final screen displays real-time transition analysis, risk levels, performance of the system. It gives a complete overview of decision making. In this system, we start from raw transition data, process it using machine learning model, generate risk resource, and finally display the result in a user-friendly dashboard for easy decision making. Thank you.
Hello everyone, I am Mohammad Ryan. Now I will explain the tools and technology used in our project. Language we have used Python because it is simple, powerful and widely used for machine learning and data analysis. And libraries we have used pandas, script, matplotlib. Pandas is used for handling dataset and MPY for mathematical operation, and scikit-learn for building machine learning models, and matplotlib is for visualization like graphs and models. We have used in logistic regression, decision tree, random tree, forest, k nearest neighbor. We use multiple models to compare performance, like simple and fast decision tree is easy to interpret. Random forest improve accuracy by comparing trees and knn models. And tools we have Jupyter Notebook, Visual Studio Code, Microsoft Power BI. Jupyter Notebook is used for development and testing, VS Code for coding, and Power BI for creating dashboard and visual reports. And concepts are machine learning, risk scoring, anomaly detection. Machine learning helps in prediction risk scoring, assign a probability of fraud, and anomaly detection identifies unusual transactions. Next slide. Here now I will explain the expected outcome of our system. The system provides accurate fraud detection using machine learning model. It generates a probability based risk score, meaning each transaction gets a score showing how risky it is. Transactions are classified into low, medium, and high risk categories. We perform a comparison of different ML model to find the best one. The result are shown using graphs and visualization for each understanding. Overall, it improves transaction risk analysis, helping organization make better decision. And so our model system not only detects fraud but also explain the level of risk clearly. Next slide. So finally, I will conclude the presentation by ending the conclusion. Our system use machine learning models to analyze transaction data and predict the risk level. Unlike traditional rule-based system, this approach is more flexible and accurate. It generates a risk score which helps in identifying suspicious transaction quickly. In future, in future, the system can be enhanced for real-time detection and can be integrated with banking system. And in our project provides a smart and scalable solution for advanced transaction risk scoring using ML. Thank you.